Hi friends, welcome back to another video. So today I'll be explaining physics October-November 2018 paper 42. Also, I want to let you guys know that more than 95% aren't subscribed, so make sure to subscribe and turn on post notifications. Question 1 states a lorry is traveling along a straight horizontal road. Figure 1.1 is the distance time graph for the lorry. So this is the distance time graph, and part A states using figure 1.1 determine the speed of the lorry at time t is equal to 30 seconds. So at 30 seconds it is at 900 meters. So speed is equal to distance divided by time, which will be 900 divided by 30, and the answer is 30 meters per second. So we will write 30 meters per second as our final answer for part A. Then in part 2, the average speed of the lorry between time t is equal to 60 seconds and t is equal to 120 seconds. So the average speed is equal to change in distance divided by change in time. So the change in distance is between 60 seconds and 120 seconds. So at 120 seconds it is at 2700 meters, and at 60 seconds it is at 1800 meters. So 2700 minus 1800 divided by change in time, which is 60 and 120. So new time, which is 120, minus old time, which is 60. So 900 divided by 60 will be 15 meters per second. So 15 meters per second will be the average speed and final answer for part 2. Part B states at time t is equal to 30 seconds, the total resistive force acting on the lorry is 1.4 multiplied by 10 to the power of 4 newtons. So in using figure 1.1, determine the magnitude of the acceleration of the lorry at t is equal to 30 seconds. So at t is equal to 30 seconds, it is 0 meters per second because the object is moving at the constant speed. So the resistive force or the acceleration is 0 meters per second because it is constant, as the line over here is straight line instead of bending upwards, or it is not bending upwards or downwards. So at 30 seconds it is at constant speed, so the acceleration will be 0. Then part 2 states determine the forward force on the lorry due to its engine at time 30 seconds. So at 30 seconds the forward force is 1.4 multiplied by 10 to the power of 4 newtons, because the total resistive force acting on the lorry is 1.4 multiplied by 10 to the power of 4 newtons. So the forward force will also be 1.4 multiplied by 10 to the power of 4 newtons. Then part C states describe the motion of the lorry between time is equal to 60 seconds and time is equal to 30 seconds. The speed of the lorry decreases to 0 and it is at stationary because it decelerates, and then after 2700 meters the lorry does not move forward or does not has an increase in the distance. So it just means that the lorry is at stop or stationary. So this is what we'll write in part C. The speed of the lorry decreases to 0 and is at stationary. Question 2a states figure 2.1 shows liquid in a cylinder. So this is a cylinder with liquid filled in it. Then table 2.1 shows some data about the cylinders and the liquid. Table 2.1 has radius of cylinder 3.5 centimeter, weight of empty cylinder is 2.5 newtons, depth of liquid is 12 centimeter, and density of the liquid is 900 kilograms per meter cube. So the cylinder containing liquid is placed on a digital balance that displays the mass in kg. Calculate the reading shown on the balance. So first we'll calculate the volume of the cylinder, which is volume is equal to pi r squared h, which is pi multiplied by radius of the cylinder, which is 0.035 square multiplied by 0.12 centimeter, which is the height. And the answer is 4.62 multiplied by 10 to the power of minus 4 meter cube. Then P is density is equal to mass divided by volume, or mass is equal to density multiplied by volume, which is density is 900 multiplied by 4.62 multiplied by 10 to the power of minus 4, which will be 0.4158, which is 0.42. then the total mass is 2.5 because when we convert weight into mass or kilograms, it is 2.5 divided by 10, which will be 0.25 plus 0.4152, which will be 0.6652. And when we convert this into two significant figures, it will be 0.67 kg. So the reading will be 0.67 kg. Part B states figure 2.2 shows a device that measures the pressure of a gas. So this is the device, and part 1 states state the name of this device. So this device is a manometer. Then part 2 states the pressure of the gas is 400 pascals greater than the atmospheric pressure. Calculate the density of the liquid. So pressure is equal to PGH. So D is equal to, density is equal to P divided by GH. So here we will do 400 divided by 10 multiplied by 0.05, which will be 800. So the density of the liquid is 800, and so this will be the final answer. Then part 3 states with the gas supply connected, the top of the tube on the left of the device is sealed securely with a rubber stopper. The gas pressure is then increased. State and explain what happens to the liquid in the device. The liquid on the left goes further up the tube because the pressure of the gas is greater than the air pressure and pressure from the liquid column. So that's why the liquid will move towards the left and top of the left side, because the pressure on the gas is greater than the air pressure and the pressure from the liquid column. So this will be the final answer. Question 3a states the velocity of an object of mass m increases from u to v. State in terms of m, u and v the change in the momentum of the object. So change in momentum is equal to mass times velocity by mv minus mass times initial velocity, which is u. Then B states in a game of tennis, a player hits a stationary ball with his racket. The racket is in contact with the ball for 6 milliseconds. The average force on the ball during this time is 400 newtons. Calculate the impulse of the tennis ball. So impulse is equal to force times time. So force is 400 multiplied by 6 divided by 1000, because we have to convert this millisecond into seconds. So it is 6 divided by 1000, which will be 0.006, and then it will be, the final answer will be 2.4 newton seconds. So the impulse on the tennis ball will be 2.4 newton seconds. Then part 2 states the mass of the ball is 0.056 kg. Calculate the speed with which the ball leaves the racket. So force times time is equal to mass mv minus mu. So we will move m to the left side and write 2.4 divided by m is equal to v minus u. So when we calculate 2.4 divided by 0.056, it will be 42.86 meter per second. So the speed will be 43.0 meters per second, because we will convert this value into two significant figures. So it will be 43 meters per second. Then part 2 states the energy transfer that takes place as the ball changes shape during the contact between the racket and the ball. The kinetic energy changes into elastic energy in the ball. Part 2 states as the ball leaves the racket, strain energy changes into kinetic energy of the ball. So this is what we'll write in part 3. Question 4 states figure 4.1 shows an apparatus used by a student to measure the specific heat capacity of iron. So this is a apparatus used to measure the specific heat capacity of iron in figure 4.1. A states the student improves the accuracy of the experiment by placing material around the block, as shown in figure 4.2. Part 1 states suggest the name of the possible material that the student could use and explain how it improves the accuracy of the experiment. Suggestions: the student can use rubber as an insulating material. Then in explanation we can write it reduces the heat loss to the surrounding as more energy is transferred into the block. So this will improve the accuracy of the experiment. Part 2 state how the student could further improve the accuracy of the experiment by using more of the material used in figure 4.2. The student can put insulation on top of the block to improve the accuracy of the experiment. So this is what the student can do to improve the accuracy of the experiment. Then B states the current in the heater is 3.8 amps and the potential difference across it is 12 volts. The iron block has a mass of 2 kg. When the heater is switched on for 10 minutes, the temperature of the block rises from 25 degrees Celsius to 55 degrees Celsius. Calculate the specific heat capacity of iron. So energy input is equal to VIT, which is voltage multiplied by current multiplied by time. So voltage is 12 multiplied by current, which is 3.8 multiplied by 600, because we will convert minutes into seconds. So 10 multiplied by 60 will be 600, and the energy input is 27,000 joules. Then specific heat capacity is equal to energy divided by mass multiplied by change in temperature. So 27,000 divided by 2 multiplied by 30, which is 55 minus 25, 30. So the answer will be 450 joules per kilograms degrees Celsius. So 450 joules per kilogram degrees Celsius will be the final answer, and it will be the specific heat capacity of the iron. So this is what we will write in part B. Question 5a states, figure 5.1 shows the visible spectrum focused on the screen by passing the light from a source of white light through a lens and a prism. So this is the spectrum which is shown by focused on screen by passing light from the source of white light through the lens and a prism. Part 1 states, state the name of the process that separates the colors in white light. So it will be dispersion. Then part 2 states, state the color of the light on the screen at point A and at point B. So at point A it will be red light because it's the starting of the colors, which is Roig wave, and then at the last the color will be point B will be violet. Then part 3 states, state the property of the glass of the prism that calculates white light to be split into different colors of spectrum, because different colors have different speeds. So that's why the white light the prism causes the white light to split into different colors of the spectrum. So this will be the final answer for part 3. Part B states, figure 5.2 shows a section of an optical fiber in air, and a ray of light is incident on the fiber wall at X. Part 1 states, on figure 5.2, continue the path of the ray of light up to the end of the fiber. So this is the ray of the light, and then we have to intersect at the same angle. It will be intersecting, hitting the optical fiber at this point, and then on top it will hit over here, and then at last at the base of the optical fiber. So 2 points at the top and 2 points at the bottom. Then part 2 states the refractive index of the material of the fiber is 1.46. Calculate the critical angle of the material of the fiber. So sin C, which is C, is critical angle, is equal to 1 divided by n. So C is equal to sine inverse brackets open 1 divided by 1.46, which is the refractive index of the fiber. So the answer of the angle or critical angle will be 43 degrees. So the critical angle will be 43 degrees. Part 3 states, state 2 uses of optical fiber. First is, it is used to carry communication. Second is, it is also used for medical diagnosis. So this is what we will write in part 3. Question 6 states, figure 6.1 represents a sound wave of wavelength 0.45 traveling from left to right. So this is the figure 6.1 with the wavelength. Then on figure 6.1, at the center of the compression, mark cross and label it C. So over here it is compression, so we'll write C. Then over here and also over here. Then part 2 states, at the center of the rarefaction, mark a cross and label it R. So over here its two lines are the greatest from each other, so this is rarefaction. then we will label over here R, and then over here, and then here and here. Then part 3 states draw a double-headed arrow to represent a distance of 0.9 meters. So it is from one compression to another compression, then another arrow from this compression to another compression which is next to it. So this is how we'll draw two double-sided arrows, headed arrows. Then part B states the frequency of wave is 750 Hertz. Calculate the speed of the wave. So speed is equal to frequency multiplied by wavelength. So 750 multiplied by 0.9 divided by 2 or 0.4. You'll write 0.45, which will be 340 meters per second. So the speed of the wave is 340 meters per second. Then question C states suggest a medium through which the sound wave is traveling and state your reasoning. So the medium is air and the reason is speed is of sound. Speed is of sound and in air, because speed is of sound waves as it is traveling at 340 meters per second, and most of the sound waves travel at 340 meters per second in air. So that's the reason. Then part D states another type of wave that consists of compression and rarefaction in ultrasound. State one similarity between the sound of frequency 750 Hz and ultrasound. So the longitudinal waves are parallel to the waves that travel in one direction. So this is what we'll write in part 1. Then in part 2, state one way in which sound of frequency 750 Hz is different from ultrasound. The frequency is less. So this is what you'll write. Question 7 states figure 7.1 shows three identical lamps and an ammeter connected to a power supply. So this is the power supply, analytical lamp connected to the power supply. Then the switches are closed. Each lamp is rated at 60 watts and operates at the normal voltage, working voltage of 110 volts. Part A states calculate the current in each lamp. So P is equal to voltage multiplied by current, and we have to calculate the current. So it will be I is equal to P divided by V, which is 60 divided by 110, which will be 0.55 amps. So the current is 0.55 amps. Part 2 states the current in the ammeter is 0.55 is in the ammeter. So if we connect at the end, these three lamps will be connected together. So if each lamp has 0.55 amps, so total will be 0.55 multiplied by 3, which will be 165. So if we round this off to two significant figure, it will be 1.6 or 1.7 amps. So the current will be 1.6 amps. Then part 3 states the voltage of the power supply. It is already stated that the normal working voltage is 110 volts. So the power supply will also be 110 volts. So this is what we will write in part 3. Question B, part 1 states calculate the resistance of a filament of one of the lamps when working normally. So R is equal to voltage divided by current. So voltage is 110 divided by current, which is 0.55 as calculated previously in previous question. So this will be 200 ohms. So the resistance of one of the lamp will be 200 ohms. Then part 2 states another lamp X has a filament with twice the resistance of each lamp in the circuit of figure 7.1. The material and temperature of the filament in lamp X is the same as the filament in the lamps in figure 7.1. In table 7.1, take any box in the right hand column that shows a possible difference between the filament of lamp X and the filament of one of the lamps in circuit. So first is X is half the length. No, it is twice the length. So it is because the resistance is high, so X will be twice the length, whereas this new circuit will have half the length. Then second is X has half the area of cross section, because when the resistance is high, it needs a high area of cross section so that the current can flow quickly. So X has a half area of cross section, whereas this new circuit will have double the area of cross section as of x. So these are the two ticks that we have to put in this table. So first is x has a twice the length, and second is x has half the area of cross section. So these will be the final answer. Question A, part 1 states figure 8.1 shows a positively charged cube of insulating material. The cube is fixed to a piece of wood that is floating on water. A negatively charged rod is held above the piece of the wood and brought close to the cube as shown. Positively charged cube of insulating material is placed on the wood which is attached to the wood, and then here is a negatively charged rod. State and explain any movement of the piece of the wood. The piece of the wood will move towards the negative rod because the opposite charges attract. Then part 2 states a figure 8.2 shows two cubes of insulating material. One is positively charged and the other is negatively charged. The cubes are fixed to a piece of wood that is floating on the water. Charged rods are held above the piece of the wood and brought close to the cubes as shown. So this is the figure on how it is done. Then the question states state and explain any movement of the piece of wood. So the piece of wood will rotate because the two forces cause the turning effect. Then part B states in terms of the simple electron model, describe the differences between conductors and insulators. So the conductors have free electrons and they conduct electricity. Whereas in insulators does not have free electrons and it cannot conduct electricity. Then part C states on figure 8.3, draw the electric field pattern around a single point positive charge. So in positive charges send have a magnetic field which is moving out from the center. So first we will put an arrow on top on each side, like first in top, right and left, and then bottom, and then on slanting sides, one right side, one and between left and top, and then one between left and bottom, and then the last one will be between right and bottom. So this is how we will draw the electric field pattern around a single point positive charge. Question 9 states figure 9.1 shows a permanent bar magnet next to a circuit that contains a coil and a galvanometer. So part A suggests a metal from which the magnet is made. So in this question we will state that which metals can be converted into magnets. So I will write 3, and first is steel, then nickel, and then cobalt. But here we have to write only one answer. Then part B states the magnet is moved to the left and inserted in a small distance into the coil. The galvanometer deflects briefly and shows that there is a current in the coil. Explain why there is a current in the coil. So the magnetic field lines cut and the voltage is produced, so the galvanometer deflects. So this is what we will write in part 1. Then part 2 states as the magnet is moving near the coil and Q of the coil behaves as a magnetic pole. State the polarity of end Q and explain why it has this polarity. The end Q is an end pole and so it repels when the north pole approaches. So this is why the end Q behaves as a magnetic pole. Then part C states suggest two ways in which the deflection of the galvanometer can be reversed. First one is insert S pole into the end of the Q, and second is insert the north pole into the other end opposite of the end Q. So this is what we will write in part C. Then A states a detector of ionizing radiation measures the background count rate in a classroom where there are no radioactive samples present. The readings in counts per minute taken over a period of time are shown in table 10.1. So this is the table 10.1 with counts per minute. Then part 1 states state two possible sources of this background radiation. First is medical sources and radon. And then second, part 2 states explain why the readings are not the same. Random variation of background radiation, because in readings are not same because there are some background radiation that are changing constantly over time, so there are random variation. Then part B states With no radioactive sample present, a scientist records a background radiation count of 40 counts per minute. He brings a radioactive sample close to the detector. The count rate increases to 200 counts per minute. After 24 days, the count rate is 50 counts per minute. Calculate the half-life of the radioactive sample. So at starting, it is 40 counts per minute. So, and after 24 days, it is radioactive material plus the background radiation is 50 counts per minute. So only the radioactive material radiation will be 50 minus 40, which is 10 counts per minute after 24 days. And at starting, it is 200 minus 40, which is the background radiation, which will be 160 minutes counts per minute of radiation from the sample. Then we will divide 160 by 10 to get the number of days, which is 16. Then when we divide 16 by 4, because it's for 24 days, and then it has 4 half-lives. So when we divide 24 by 4, it will be 6 days. So the half-life of this radioactive material is 6 days. So we write 6 days as the final answer. Question C states, draw a line between each type of ionizing radiation and its property and another line between the property and its use. So for X-ray, it can pass easily through soft living tissue. Calcium absorbs more than soft tissues. So its use is detecting fractures in the bone. Then second is alpha particles. So the property is it is the most ionizing radiation and is most easily absorbed by very small amounts of substance. Then the use of alpha particle is used in detecting smoke in fire alarm systems. Then beta particles property is penetration is affected by small changes in the amount of solid it is passing through, and the use is detecting a change in the thickness of aluminum foil during its manufacture. Then gamma rays property is it is highly penetrating and is poorly ionizing, and its use is remotely detecting leaks in underground water pipes. So this is how we will connect alpha, beta and gamma rays with these three properties, and then connect the properties with its uses. So this is the final answer.